Okay, so far we talked about how to find dot product. We talked about how to put a vector in component form, and we talked about how to put it in terms of, in a linear combination of I and j. All right, now we're going to go a little bit more. So do you remember in section 1, let's go back to section 1. Oh, this isn't the inked version, but you have the inked version with you. We said that in order to find this x component, remember, we said, okay, this is the adjacent and this is the hypotenuse. So cosine of theta is x over v. Do you remember we did that? So cosine of theta is x over v. And then what did we do? We multiplied by v, we multiplied by v. So x was v cosine theta, right? And then the same way, what did we get for y? It was what? Y was v sine theta, right? So they're always going to look like that. So what I tell my students is I would like us to be at a point where we skip the step on top, we just go to the one in the green, where x is v cosine theta, y is v sine theta. And remember, we always draw our triangle like this, so that it's consistent with what we were doing last semester. The vertical is always the sine because it's the opposite, okay? So vertical is always sine, horizontal is always cosine. We're going to use that more powerfully in this section. So I have them again here. In lesson 1, I say we learned that x is v cosine theta, y is v sine theta, right? So now, remember how we were writing our vectors in component form? It looked like this, a, b. So basically, like an example would have been 4 comma negative 2. Remember that? So if you look closely at that, this first one is the direction along x, and this second one is the direction along y. Okay? So if this is x and this is y, well, what did we say x was? V cosine theta. So this could just be v cosine theta. And then the other one, v sine theta. So we could write it like that. Okay? What does all that mean? Let's do an example. We want to find the component form of v with, this is the important part now, magnitude 7, direction angle 60 degrees. Those are the important parts, okay? So what I do is this, v equals v cosine theta, v sine theta. I always write that. I always write that first. V cosine theta, v sine theta, because that's x and that's y. All right. V here inside is the magnitude. Okay? So that's the magnitude. So I'm going to have 7 for v. Okay, and then cosine theta, what's the angle I have? Cosine 60, right? And here again, it's 7 sine 60. All right, so 7 cosine 60, 7 sine 60. And then I just have to put these in my calculator. All right, what's cosine of 60? Do you remember? Not pi over. It's either 1/2 or root 3 over 2. It's root 3 over 2. And what's, sorry, it's, sorry, cosine is 1/2, and the sine is root 3 over 2. So, so that'll be like 7 times 1/2, which will be 3.5. All right, so here, 7 sine 60. Yeah, and you have to make sure, right, that you're in degree mode, okay, for these. So it's 6.06. We can go to 1 decimal place, that's fine. So this is going to be 3.5 and 6.1. Okay, so that's how we write a vector in component form. That's the answer. So basically, again, to recap, all right, when you want to find the component form, just do v cosine theta, v sine theta, and then we put in the magnitude and the angle. Okay? All right. Now, how do you find the direction of an angle? Well, suppose you're given vector AB, right? Remember, this is the x component and this is the y component. If you were to graph a vector, so suppose your vector is 3, 4. Okay? What does that mean? How much do you go over horizontally? 3. And how much do you go up vertically? 4. So you're there, right? Okay. You want to find this angle, let's say, theta. How would you do it? Well, we draw a triangle, right? A right triangle. And how big are the lengths of the triangle? 3 and 4. So now, if this is my theta, and I have adjacent and I have adjacent and opposite, which one of the functions is that? Adjacent and opposite is tangent. So I just do tangent of theta is 4 over 3. Do you have to draw it every single time? You don't. You could just remember that. Right, exactly. So 9 over 2. So here you have the vector P. You're going to do tangent of theta is equal. Oh, no, I have it wrong. It's y over x. That's why you were mistaken. I'm sorry, I have that wrong. It's y over x. Let's fix that. It's y over x. So tangent of theta is 9 over 2. So theta is inverse tangent of 9 over 2. Right? And if we do inverse tangent, sounds pretty right. 77.5. Okay? All right, so now for the big idea. Okay? So now for the big idea. Suppose the pilot is flying a plane, right? And they have their route set. They basically have to go, horizontally east. Okay, that's how they're flying. But suppose there is wind, because there's always wind, right? Suppose there is wind blowing in that direction. What's it going to do to the nose of the plane? It's going to tip the plane a little bit, right? It's going to tip the plane up a little bit, right? So at the end of the day, it's going to fly in that direction, right? Which means if it was trying to go to this city, well, guess what? Now it's going to land in the city next door, right? It's not going to land in Burbank. It's going to land like somewhere else where there is no airport. Not cool, right? Also, if the wind is pushing backwards on it, what's going to happen to the speed of the plane, you think? It's going to slow down, right? So, guess what? How does like control center figure out what the pilot has to do to compensate for this? Well, believe it or not, it's all about vectors. Because the plane, the direction of the plane is a vector. The wind is another vector. We add the vectors, we get the resultant, and then we can figure out mathematically what the final direction and speed are going to be. All right? So let's do that. Let's talk about resultant, speed, and direction. So in 8.1 again, we said that the resultant was just vector A plus vector B, right? We had the handout and da-da-da, and we did it on the board and da-da-da, all right? We can use the same definition to find the magnitude and direction of a resultant vector. Remember on the handouts, there were the worked out solutions, and I said we're going to do that later? Well, now it's later, okay? Okay, so I'm going to walk you through one example, and I have it broken down into 5 steps. So let's do this. So suppose vector A has a magnitude of 10 and makes an angle of 25 with the horizontal. Vector B has a magnitude of 5 and makes an angle of 30 with the horizontal. Okay, so what we're going to do is draw the resultant vector. All right, now magnitude of 10 and an angle of 25. So look, if this is the horizontal, it's got an angle of 25 and a magnitude of 10. I eyeballed it, right? I eyeballed the 25. Now the other one has a magnitude of 5 and an angle of 30. Magnitude of 5, so basically that's half the length, right? And an angle of 30. And I have to draw that second vector where? Here, right? So at the tip of it. So let's see, if that's the horizontal, here's how that goes. So like 30 degrees, like that. Okay. So what does the resultant look like? This. Okay. So we just drew the resultant. Perfect. Okay. Now, here's what we're going to do. We're going to write vectors A and B in component form. I'm going to color code this as much as I can. So step 1, you can do it if you want. You can do it with it. You can actually solve this problem without drawing them. Drawing them just gives you a visual, right? Okay, so write A and B in component form. Okay, so let's do vector A. Okay, so vector A, we're going to do magnitude cosine of theta, magnitude sine of theta. So it's going to be, so the purples are vector A. So 10 cosine of 25, 10 sine of 25. Okay. First, now we're putting it in component form. All right, so this is going to be 10 cosine 25. Yeah, and 10 sine 25. So 9.1 and 4.2. So A is 9.1 and 4.2. Okay, B, we're going to do the same thing. This time it's what times what? What's the magnitude? 5 and 5 sine 30. So 5 cosine 30 is 4.3. And sine of 30 is a half, so that's just going to be 2.5. If you don't believe it, if you don't believe yourself, you can check with the calculator. All right, so I've done that. Now it says to add vectors A and B, right? So how do we add vectors A and B? That's going to be vector R, A plus B, right? So vector R is going to be, all right, I'm going to add corresponding components. 9.1 plus 4.3, 4.2, and 2.5. So 9 plus 4, that's 13.4. 4 plus 2 is 6.7. This is vector R. So to get to vector R, I go 13.4 horizontally and 6.4 up. And that sort of makes sense if you see the drawing, right, of R? Okay, so now, to find the magnitude of R, use the modified distance form. Remember, so that's like the square root A squared plus B squared. Yeah, so let's do that. So R magnitude is the square root of 13.4 squared plus 6.7 squared. Okay. So that's the square root of 13.4 squared. Yes. 14.98, so that's pretty much 15.0. And then to find the direction, I copied and pasted. So it's going to be tangent is y over x. Let's fix that. Tangent of theta is 6.7 over 13.4. So theta is inverse tangent, 6.7 over 13.4. So inverse tangent, 6.7 over 13.4, 26.6 degrees. Okay, so there we have direction and magnitude. Okay, all right, so let's do one where I haven't broken it up into 5 steps, but we're going to do the 5 steps. Okay, all right, so here we go. A soccer player running forward at 7 meters per second kicks a soccer ball, so he's running forward at 7 meters per second. He kicks a soccer ball with a velocity of 30 meters per second at an angle of 10 degrees with the horizontal. What is the resultant speed and direction of the kick? So this guy is running forward at 7 meters per second. And if he's running forward, right, he's a soccer player, he's not playing on an incline, right? It's just a flat surface, so it's a horizontal line. And then he kicks the ball at 30 meters per second at an angle of 10 degrees. So 30 meters per second. So if this is the horizontal, 10 degrees is super little, like that. Okay? So the resultant is this one right here. Okay? Right? So if he's running, and if you see like the angle that the foot makes and the angle that the ball makes, they're not going to be the same. Okay. So now, what is the resultant speed and direction of the kick? All right, so step 1, we drew the vector. Cool. Step 2, write the 2 vectors in component form. Well, there's the purple and the blue. The vector doesn't have to have a horizontal, like it doesn't have to have a slant. It could be horizontal and vertical as well. So, step 2, right? So, let's call these, what should we call these? So, let's call this vector P, right? Because that's the player. So, P, right? Okay, so now, if it's a horizontal vector, right? Look, what's the angle that it makes? 0. So you could do it both ways. You could do 7 cosine 0, 7 sine 0. What's cosine of 0? 1. So that's just 7. What's sine of 0? 0. Could we have written that without sine and cosine business? Right? Because this is just horizontal, I go 7 in the x, 0 in the y. Okay? All right, what's the other one? Well, let's call that vector k for the kick. All right? Or the ball. Let's do the b for the ball. I don't know, whatever, it doesn't matter. So now that's going to be what cosine what? 30 cosine 10. 30 sine 10. And anybody? 5.2. Awesome. Okay, so that's step 2. Now, what was step 3? Add them. All right, so when I add them, I get my resultant. That's P plus B. So that's going to be 7 plus 29.5, 0 plus 5.2. That's 36.5, 5.2. Now, step 4, find the magnitude. That's the square root. Oops. And that'll be in the square root, 36.5 squared, 5.2 squared, 36.9. Are there units to this? Meters per second. And then step 5 is the direction. Tangent of theta is 5.2 over 36.5. So theta is inverse tangent of all of that. Right? 8.1 degrees. All right? So magnitude, direction. Okay, so this is why we do this. And does that make sense? So he kicked the ball at 30 meters per second, like he gave it an initial velocity of 30, but because he was already running at 7, the ball flies with a velocity of 36.9. Okay? If he was just standing and kicked it at 30 meters per second, the ball would just fly at 30 meters per second. Right? Okay. So I do have a little bit of a practice for you guys right now. This is the end of the lesson. After the practice, the homework for part 2 will be due tomorrow, and I have a practice quiz as well.